So here's the continuation of the set of solutions to the homework quiz on sections 2.6 and 2.7. Number 4 wants us to find an equation of the tangent line to y equals 3 to the x at x equals 1. Well, if we want the equation of the tangent line, we're going to need the slope of the tangent line evaluated at x equals 1, and that's going to correspond to our derivative evaluated at x equals 1, or f prime of 1. So we've kind of looked at several different notations throughout chapter 1. This is Leibniz notation. The derivative evaluated at x equals 1 is still going to correspond to f prime of 1. It's just a slightly different notation. Now this derivative of 3 to the x is going to require use of a formula that we did develop and we used a little bit. We didn't use it an awful lot. We used the one for e to the x a little bit more. But whoops, I didn't want to do that. That was supposed to be an a, alright, not a 3. So I wanted that to be an a, just some number raised to the x power, and I refer to this as a general exponential. The derivative of a raised to the x power is going to be the same exponential times the natural log of the base. Okay? So the derivative of 3 to the x using this formula is going to be 3 to the x times the natural log of 3. So our derivative dy dx is going to be equal to 3 to the x times the natural log of 3. We want dy dx evaluated at 1 so that we can have the slope of the tangent line at x equals 1. So evaluating this at 1 is going to leave us with 3 to the first, which is just 3, times the natural log of 3. Now I don't know what the value of that is. The calculator could estimate that for you. Let's just leave it in this exact form as an irrational value. So I'm just going to leave my slope like this, kind of an ugly slope, but it's still a number, it's still a slope. If I'm looking for the equation of the tangent line, I'm going to need to find the point of tangency. The point of tangency has an x value of 1 and a y value of f of 1. And if I compute f of 1, that's just going to be 3 to the first, which is just 3. So I need to conclude this by finding an equation of the line that goes through this point and has this as the slope. So I'm going to go ahead and use point slope form, which is going to be y minus y1, and for y1 we found 3. And y1 is just the y coordinate of a point on the line. Here's the slope, 3 natural log of 3. So y minus y1 equals m times the quantity x minus x1, and for x1 it's the x value that corresponds to this y value on the line. So there's an equation of your tangent line. If you went for, oops, sorry, I got that off the screen there a little bit, didn't realize I was doing that. But y minus y1 equals m times the quantity x minus x1. We'll take a look at the last problem here in a third video.